Right, this video is going to be about how to turn atoms into ions. So I've had a few people question me on the work I set a little while ago that they got drawing the atoms, that was fine, but turning them into ions was where the problem arose. So before we get started, I just wanted to do a quick recap of the definitions of these two key terms. So atoms are the smallest part of an element that can exist. Okay. And by their nature, the charge of an atom is neutral. So neutrally charged. And that is because their number of protons equals the number of electrons. Whereas ions are charged particles. Okay, and they're charged, which means they have either a positive or a negative charge, and it can be a multiple of 1, 2 or 3. And they're charged because the number of protons does not equal the number of electrons. Okay, so that's a key point. So ions are elements that are charged, usually because they've been involved in some sort of chemical reaction, and they are charged particles because that number of protons does not equal the number of electrons. And remember, protons, they begin with P and they're positive, and electrons are negative. Now atoms also have neutrons within them, but we do not need to worry about neutrons just for the purpose of this explanation. So we're going to go through drawing two types of ions today, so positive ions and negative ions. So I'm going to pick an element from group 1, which is going to be sodium, and I'm going to pick an element from group 7, which is going to be chlorine. Okay, so sodium is group 1, which means it has 1 electron, so 1 electron in its outer shell. So when it forms an ionic bond, it will lose that electron. Okay, so which it will lose. Whereas chlorine is in group 7. So it has 7 electrons in its outer shell. To get a full outer shell of electrons, it will gain 1 electron. So therefore, it will gain 1 electron. Okay, so first off, I'm going to get my periodic table out. Just bear with me a moment. So periodic table is here, and we can see that sodium in group 1 has a proton number of 11, but that's also going to be the number of electrons in the atom of sodium, because remember, in atoms they're neutrally charged and the number of protons equals the number of electrons. So sodium has 11 protons and therefore 11 electrons. So let's just draw that out. So sodium, 11 electrons. Okay, so we're going to remember the rule. So we're going to do the chemical symbol in the middle. We're going to do the first shell. It has 2. In the first shell, we have to fill up from the first shell, and then the second shell has 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the third shell has just the 1 to make it up to 11 electrons. Okay, and remember we said it's going to lose that electron to form a charged particle, to form the ion. So in order to lose that electron, we're just going to take away that outer shell. So the ion becomes, Na cross cross, so 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we don't need to draw the third shell because there won't be any electrons in that shell. Now, because it's an ion, we put these square brackets around it. Okay, and now because it's lost an electron, but it still has the same number of protons, it's going to have one more proton than it does electrons, so its overall charge is going to be positive. So you just put a plus up there. Okay. Right, so next then, we're going to move on to chlorine. Again, I'm just going to check in my periodic table. So chlorine is in group 7. Its proton number is 17. And remember, protons and electrons equal the same, so 17 electrons. Okay, and we're going to follow our shell filling rule. The only thing is, here I'm going to draw the electrons as dots. Okay, so we've got crosses on this one and we've got dots on this one, and there's a reason for that, and we'll come to that later. So 1, 2, second shell, 3, 4, 5, 6, 7, 8, 9, 10. Third shell. 11, 12, 13, 14, 15, 16, 17. Now, because it's in group, because it's got 7 electrons in its outer shell, in order to get a full outer shell and make an ion, which is more stable than the element is on its own, we're going to gain 1 electron. So all we need to do this time is we have to draw out the atom exactly as it is first off. So chlorine, so 1, 2, okay, 3, 4, 5, 6, 7, 8, 9, 10. Third shell, 11, 12, 13, 14, 15, 16, 17. Okay, and then that final electron, I'm going to draw it as a cross because that final electron will actually have come from up here, from sodium. Okay, so it will have come from the outer shell of an element that's going to form a positive ion, and it will come and hang out with chlorine and it will form a negative ion. So because chlorine now has 1 more electron than it does protons, it's going to be overall negative charge. So you do the square brackets again and you put the negative charge up there. So sodium will always form a positive ion, which we write as Na+, and chlorine will always form a negative ion, which we write as Cl-. Okay, and you know, or you will come to know, that sodium chloride is a very common compound that we discuss in chemistry, and its chemical symbol is NaCl. There are no numbers, no charges or anything, because when they exist together, they cancel out the charges, and you only need 1 sodium ion to cancel out 1 chloride ion. So chlorine, the element chlorine, becomes chloride when it's an ion, so it's sodium chloride. Okay, I hope that's explained how we're forming the ions a little bit better. Our next video, we're going to actually talk about this ionic bonding in a little bit more detail and how you would represent that. But for now, I just want you to be able to look at an element and figure out what kind of ion it's going to form without the complication of where it's going to bond with. Okay, have a good day. Bye.